Welcome in our today's class. And today I want us in our maths class to look at what we call scale drawings. This may look new, but I want you to take back your mind to various maps that you might have come across or seen, topographical maps and so on. Now, scale drawing has simply been used to represent some information of the actual ground or actual object simply because they cannot fit on a small piece of paper or on a page. So, because we cannot represent real objects, distance, on a page, then we are required to scale them down so that they can fit a page. When that happens, then we say we shall be drawing the actual length or distance of the object to our pages using a certain scale. So those objects with large dimensions cannot be drawn on a small page until we assign or we scale them down. And some are very tiny. When they are very tiny, again, we have to scale them up so that they can give us some reasonable readings. If a scale drawing has a ratio of 1:1, this means that what we have as a real object is simply exactly the same as what we have as the drawing. A good example is just a practical map, and I want us to take a simple look, maybe even to a compound of the school. This is just a sketch. Maybe our compound of the school looks like this. Measurement in meters of a compound. Now, this compound is measuring these meters, but can we carry this and put it on a page? No, we have only sketched. So what it means that we need to assign a scale, and that scale will help us to draw this shape exactly on our books with the correct measurement, only that they are in form of a ratio, so that you can later on convert to find the actual measurements. If you choose to travel between two towns, maybe between two towns, more than this, several kilometers away, and then you are told to represent your journey in your book, you'll use scale drawing to scale down and assign a correct scale. Then you'll be able to find out how far did you travel by simply drawing according to a scale that you have assigned. So in this topic, we are going to see how we can simply represent actual information on the ground, right on a small piece of paper. So in scale drawing, a scale drawing has the exactly shape as the shape of the original object. The only difference is that the dimension size has been scaled down or reduced. And if the actual object was tiny, it has been scaled up or increased to a certain ratio. So it is necessary in scale drawing that we must indicate the ratio. You must indicate the ratio every time you are drawing, you are working on scale drawing. A ratio like 1 to 50,000. Then it means that the first one is the drawing length, and the second one is the actual length. Right? That's what we have. In a scale, we represent by starting with the drawing length to the actual length. Now, the drawing length represents the length or the distance on the diagram, while the actual length represents the actual or true object dimensions, either on the ground or whatever the object we are trying to represent on our scale. When we talk of scale ratio, for example, (1 to 100), it simply means this is the drawing length. It means that for us to arrive at the actual length, it is 100 times, because this is 1. So the second part, it gives us, the actual distance is 100 times larger than the drawing distance. And if it's the other way around, for example, 20 to 1, you have started with the what? Drawing distance to actual distance. Then the drawing distance is 20 times larger than the actual distance. This is a situation where maybe we have magnified some microorganism or small parts that we cannot easily see them through. So we magnify by increasing the length. So the ratio of this one represents the drawing distance is 20 times larger than the actual distance. In scale drawing, it is very important and helpful if a scale begins with 1 to the other. If a scale begins with 1, it is very easy for us to interpret that scale. Why? Because the second number that will follow here will be our scale factor. It will be our scale factor. So when we say scale factor, it is just trying to tell us the number of times that this actual distance is from the drawing length. However, it is difficult when we have the first number starting with a different number, like for example, what we had 20 to 1. This requires to be first converted so that we can get actually the exact what the scale factor is. Another very important point to note is conversion. To convert a scaled distance to actual distance, you only multiply by a scale factor. As simple as that. So you shall be able, as long as you have the scale and the first digit is 1, then the scale factor is simply known. And simply when you are converting the actual or the real distance into a scaled distance, then you'll divide by a scale factor. So to convert scale distance to actual distance, you multiply by the scale factor, and to convert actual distance to scale distance, you divide by the scale factor. Conversion of units. In scale drawings, it is very important for us to remember the conversion of units, the relationship between various units used in measurement, especially when we are talking about millimeters, centimeters, meters, kilometers, and so on. We must know about conversion. So here, you all know we have a table. You should be able to have a table like 1 kilometer is equal to how many meters? You specify. 1 meter is equal to how many centimeters? 1 centimeter is equal to how many milliliters? Millimeters, sorry. And so on. Be conversant with the units of conversion. We have a map which has a scale of 1 to 20,000. Find the actual distance for each scaled distance. And the scale distance, first one is 2 centimeters, 5 millimeters, and 14.3 centimeters. So we said, if we want to convert, if you remember the table, the diagram we had, if you want to convert scaled distance to actual distance, you will multiply by the scale factor. And if at all the scale has been given 1 to something, the 1 will remain, but the second on which we are looking at, it will be our scale factor, which we have to multiply with. So for this particular case, if our scale is 1 to 20,000, then it means that For us to get the actual distance, we shall be required to find what is scaled, multiplied by the scale factor. And the scale factor here is 20,000. Therefore, 2 centimeters will be multiplied by the scale factor. So actual distance is equals to 2 centimeters multiplied by the scale factor of 20,000. What you get is what? 40,000 centimeters. And when you look at 40,000 centimeters, it is equivalent to how many meters? Or when you divide by 100, 400 meters, or if it is in kilometers, 0.4 kilometers. So that is the actual length or distance of the ground. Find the actual distance given that we have 5 millimeters scaled. It has been scaled to 5 millimeters. Then the actual distance will be 5 millimeters multiplied by the scale factor. This one will give us simply 100,000. If you don't want to write it as millimeters, you can convert. This is equivalent to so we are looking at millimeters, 100,000 millimeters. We need to do the correct conversion here. 10 millimeters makes 1 centimeter. So this is equivalent to 10,000 centimeters, not 1,000. 10,000 centimeters or 100 meters or 0.1 kilometers. Matter of concern is the way you convert your units. For the last one, the actual distance will be given by what we have, the scaled distance 14.3 centimeters multiplied by the scale factor, which is 20,000. When you multiply this, you'll get 286,000. You can use your calculator to convert this. It's better to put the units. Change this one into meters and into kilometers if you wish. This one can be either written as we have either 2,860 meters or 2.86 kilometers. So you can reduce that to that. So this one is the actual distance, but this one is the scaled distance. Scaled distance. If you are very keen, looking at the units, it is very important that we must make sure that our answer and the units are always there. And let us convert the units to sensible ones. Don't just give an abnormal unit here. Make them sensible units. So here we are being asked to look at the model of a boat which has a scale of 1 to 500 and find the scaled length of the following, and the first actual length is 50 meters, then 75 centimeters, and then 4,450 millimeters. So the question is asking us to find the scaled distance. We saw earlier on in our diagram that if we have to convert from scaled to actual distance, what do you do here? You multiply by the scale factor. But from actual distance to scale distance, you divide by the scale factor. So we are going to observe that as we work out this. Looking at the first one from here, this is the scale. What is our factor, our scale factor? Because this is what 500, then our scale factor is 500. So I expect you to be able to divide by 500 every time you are working on that. So this simply means this. Our scaled distance scaled distance equals to 50 meters divided by 500, where 500 is our scale factor. Looks a bit awkward, so let us convert it to centimeters. This is equivalent to 5,000 centimeters divided by 500. So the actual distance on the ground you will get is 10 centimeters or 0.1 meters. So instead of drawing 50 meters, we shall take our paper and use a scale of 1 to 500 and draw a line of 10 centimeters. We are done. We have represented the distance. Note that we are dividing because we are moving from actual distance to scaled distance. That's why we are dividing. "75 centimeters. This is interesting. When you look at scaled distance, Scaled distance is equals to actual distance divided by the scale factor. Actual distance is 75 centimeters divided by scale factor is 500. We always like to work in a simplified manner, so let us convert the units further into millimeters. This one will give us 750 millimeters divided by 500. If you choose to do that, you will get 750 divided by 500 is same as 75 divided by 50, which is 7.5 divided by 5, which is 1.5. 1.5. And because these millimeters, give it millimeters. So it's telling us that to represent a distance of 75 centimeters using a scale of 1 to 500, we only need to draw simply 1.5 millimeters. That's what we do. Now let us look at another one where we have 4,550 millimeters and our scale factor is 500. We are asked to find the actual distance. (4,550 millimeters divided by 500. What happens there? This one by 100 here is 5, by 100 here is 45.5 divided by 5. The answer should be in millimeters. So 45.5 into 5 is 9.1 millimeters. So for this case, we shall be required to simply draw a 9.1 millimeter, and we shall be through to in representing our information above. So in most cases then, it is very important for us to know the scale factor, simply because either side, whether you are converting into actual distance or you are converting from actual distance into scale drawing distance, then you must know the scale factor. And for us to know the scale factor, you simplify and simply look for, read the value of the second value given that the first value is 1. So when you reduce it to 1, then it is easier for you to move ahead and find by scale drawing both the actual distance and the scale distance. There are some situations when we don't have the scale factor and we are asked to determine the scale factor. This may be possible given the following: given the actual distance as well as the scale drawing distance. You can use the two to determine the scale factor. Let us look at the following questions and then we see what this means. Determine the scale factors of the following. 4 millimeter on scale, or 4 millimeter on scale drawing represents an actual distance of 50 centimeters and an actual length of 0.1 millimeters is represented by 3 centimeters on a scale drawing. To guide us here is the relationship that exists between actual distance and scaled distance. When you look at this, scaled distance divided by x is actual distance. How do we get x? You take actual distance divided by scaled distance, you get the scale factor. Or actual distance divided by x, you get scaled distance. If this divided by this is this. Same applies when actual distance is divided by scale distance, you get what you divided by. That's what you are looking for. So, in this case, what is our actual distance and what is our scaled distance? So here, we are supposed to understand what we are actually doing. What we have here is already a scale. So I want to say a scale is given by simply the distance on the scale drawing to the actual distance. So in the first question, 4 millimeter on scale drawing, so I'll write here 4 millimeter, should be able to represent actual distance of 50 centimeters. And this one, is it in the same units? If not, convert all into the same units. So 50 millimeters, 4 millimeters and 50 centimeters, we have to convert by multiplying 50 by 10 so that we have 4 millimeter to 500 millimeters. So I've removed the units because everything is in millimeters. So you look for a way, because we are supposed to find a scale factor, therefore we must reduce the first one and give us a scale where we have 1 to something. So it means that we must first find the scale ratio of the first question. And the scale ratio will be equal to 4 divided by 4, you get is 1. 500 divided by 4, you get it is 125. So having written this class, 1 to 125, someone tell me what is the scale factor in this ratio? You should have found the same answer as mine, that because this is 1 to 125, then it means that the second part of it is our scale factor, which is 125. So we can say that the actual distance is 125 greater than the scale drawing distance. Second question. An actual length of 0.1 millimeters is represented by 3 centimeters of the scale drawing. To approach this, let us come up with a scale ratio. Which is given by the drawing or the scale distance. And the scale distance in this case is 3 centimeters. To the actual distance is 0.1 millimeters. So, are the units the same? If they are not the same, let us convert. So we shall multiply the left-hand side, that is 3 centimeters by 10, so that we have 30 to 0.1. This one requires us to change further and make sure this is 1. While we were studying decimals, we say to remove a decimal, we count how many decimals are there on there. After the decimal point, if it is 1, we multiply by 10. If it is 5, we multiply by 100,000, things like that. So this is only 1. Multiply here by 10. Multiply here by 10. So we shall have 300 to 1. These 300, remember, the ratio, our scale ratio starts with the scale drawing, that is the first part we give. The scale ratio is given by the scale drawing distance, that is the 300 to the actual distance, which is 1. If the case is here and we have it 1, then this situation means that the scale distance here is 300 greater than the actual distance. That is what this information means. So then the question now comes. What is the scale factor? Look here very carefully. What is our scale factor? Our scale factor should be a scale where the scale distance multiplied by the scale factor is actual. You can do it very slowly and you see. When I do it from here, 300 multiplied by x is equals to 1. You realize that common sense will tell you x is 1 over 300. So this 1 over 300 is our scale factor. That one gives us our scale factor. So we should be able to approach these questions from any angle and get 3 things. 1, be able to get the scale factor. 2, be able to form a scale ratio. And 3, given the scale ratio, you should be able to find the actual distance or object distance, or if not that, we should be able to get the scaled distance. That is what matters in scale drawing. Let's start with the question here. You all know what maps are, especially topographical maps. the what we call world maps, those maps which shows the continents, the towns, and so on. All these maps were written according to a certain scale. The scale keeps on differing from one map to another. Our question is asking us to do the following. Our map has a scale of 1 to 50,000. How many centimeters in real life does 1 centimeter on a map represent? So they have asked how many centimeters, not just the distance. So don't give your answer in meters, kilometers, or whatever. No, we want to specify this straight. They are asking us how many centimeters does 1 centimeter on a map represent. Guys, kindly, this is a map which has a scale of 1 to 50,000. Everything here we are being asked is in the same unit of centimeters. Precisely, this simply means for every 1 centimeter, it is representing on the ground 50,000 centimeters, period. No calculation is only by observation. Unless if we were asked to give our answer either in meters, in kilometers, and other units, then we would be required to convert. But this is the first way to approach a question that is straightforward like that. I told you it's very important to know how to convert. So let us convert this. Convert 10,000 centimeters into millimeters, meters, and kilometers. So let us start by simply, I'll approach it unitary way. Relationship between centimeter and millimeter is 1 centimeter is equal to 10 millimeter. So, if we talk of 10,000 centimeter, it will mean multiply by 10 millimeters over 1. This gives us 100,000 millimeters. Therefore, 10,000 centimeters is equivalent to 100,000 millimeters. Convert 10,000 centimeters into meters. We know a meter is bigger than a centimeter. Therefore, one meter is equals to 100 centimeters. How many meters will give us 10,000 centimeters? Now this one is simple because if we can say 100 centimeters is 1 meter, which means we shall take the total number of meters we have, we divide by the number of meters that makes 1 meter, the number of centimeters that makes 1 meter. 10,000 centimeters 100 centimeters. If 100 makes 1 meter, to get meters out of 10,000, we shall just divide by 100. If we are doing it like this, there's something we call cross multiplication. Such that we find that to get the value here, which in this case I'll call y, we shall say this. That y times 100 is 100y is equals to 10,000 times 1, which is 10,000. So to get y, which is in meters, we divide by 100, divide by 100, you get y is equals to 100 meters. Therefore, 10,000 centimeters is equivalent to 100 meters. 10,000 centimeters is equivalent to 100 meters. Supposing we are interested in converting our answer into kilometers. This is systematic. We can write it slowly and see. I'll start with the list. 100 centimeters is equals to 1 meter. 1,000 meters is equals to 1 kilometer. So if you look at this, the relationship here, for us to arrive at a kilometer, you'll find that 1 kilometer will be represented by what? 100 multiplied by 1,000. Therefore, we are saying 100,000 centimeters is equals to 1 kilometer. But they want us to convert 10,000 centimeters. So if 100,000 centimeters is 1 kilometer, how many are 10,000? This one requires us to take the number of units we have, divide by what the units makes 1 kilometer. So it will be, to find the value here, which I'm calling x, you'll find that it will be x is equals to 10,000 divided by 100,000. You can simplify by a number of zeros. 1, 2, 3, 4, 1, 2, 3, 4. So it is becoming 1 over 10, which is the same as 0.1 kilometers. 0.1 kilometers. When we converted this one into meters, it gave us 100. So generally 100, when you divide by 1,000, you'll still get 0.1 kilometers. Determine the scale ratio of the following. Determine the scale ratio for each of the following. They are asking us to determine the scale ratio. Your answers should be in a scale ratio form. That's what we are looking for. Determine the scale ratio. So here, the 2 millimeter on scale drawing represents we have 50 centimeters. Represents 50 centimeters. So the ratio is usually given by what? Ratio is given by scale drawing to actual distance. Scale drawing distance to actual distance. If you are to do that, what is the scale drawing distance here? It is 2 millimeters. To what is the actual distance here? It is 50 centimeters. We cannot have the scale without converting everything into same units. So we have to have the same units. If we must have the same units, then it means that we convert the 50 to be into millimeters, and you'll find that this will be 2 millimeters to 50 times 10, which is 500 millimeters. A scale is usually given in a form where we have 1 to something. So this one should be simplified further from 2 to 500. We divide both sides by 2. So when you divide this side by 2, you get 1. Divide this other side by 2, you'll get 250. So our scale for this particular question is 1 to 250. If we had been asked for a scale factor, because our first term is 1, then our scale factor is the second term, which is 250. So we are looking at how to represent, to determine the ratio, scale ratio of actual distance of 7 millimeters represented by scale drawing distance of 4.9. Take note that our ratio is given by scale drawing distance to actual distance. Scale drawing distance in this case is 4.9 centimeters to actual distance, which is 7 millimeters. See? This is what we have. One side in centimeters, the other side in millimeters. We must convert to make them the same. So we change centimeters into millimeters, which means we multiply by 10, which will give us 49 millimeters to 7 millimeters. Now that it is like that, 49, we can simplify because this is 49 to 7. Divide both sides by 7. You will get 1. Divide this other side by 7. You get 7. So this is the scale ratio. Looking at this, scale ratio is given by scale drawing distance to actual distance. And our scale ratio was what? Our scale ratio here has been given by us 4.9 centimeters. Take note of the units very clear. To 7 millimeters, which is our actual distance. Now, when we convert into, when we make them same units, it is 49 millimeters to 7 millimeters. Simply multiply this 4.9 centimeters by 10. That's what you have. So the scale becomes 49 to 7, and 49 to 7 can be simplified further by simply dividing both sides by 7. Divide this side also by 7. 49 by 7 is 7, and 7 by 7 is 1. So our scale is simply 7 to 1. Take note that 7 represents the scale drawing distance, while 1 is the actual distance. If we had been asked for what? For a scale factor, then our scale factor here would be 1 over 7. So to get the actual distance, we have divided the scale drawing distance by 7 to arrive at that particular end. So in most cases, if I am to summarize this and what we've gone through, you find that in scale drawing, it is a matter of representation. You'll find this further in your science, where you'll see that most of the topographical maps have been drawn to scales. And today in mathematics, we are saying that we can use the scale to find the actual measurements on the ground, be it the length of a train, be it the height of a skyscraper, or be it maybe the distance between towns and so on. We use scale drawing to represent this information. What is very important, you must be able to determine what we are calling the scale factor. And a scale factor is only known when you have the scale ratio and has been reduced at one side, we have 1. Then it is easier for us to identify the scale factor. So that is it for today about scale drawing. Thank you.